Hello guys, we are back with another lead code problem. We are continuing our series of recursion and backtracking. Let's see the today's problem. And today's problem is combination sum second. It's a media question and highly liked. Let's dive into the question. First and foremost, this question is pretty much similar to the combination sum, but there is a sum constraint here that make this question differ to the combination sum. So first and foremost, let's dive into the question. What's actually question asked? So you have a given a collection of candidate numbers, candidate, and a target numbers, target. You have to find out all the unique combination in the candidates where the candidate number sum to the target. So that's the similar question to the combination sum. You have a given an array of the candidate and given a target integer. This name is target, and you have to find out all the unique combination in that candidate where the candidate number sums, total sum of the number sums, that must be equal to the target integer. So that's pretty much the same question, but there is one condition added here. Each number in the candidate may only be used once in the combination, so there's not repetition is allowed. You can pick only one time. And here is a one note, the solution set must not contain duplicate combination, so we don't add duplicate element. We can't, let's say in this case we can generate 8 in that case, adding 1 and 6, 1 and 7, we can generate 8 as well. But if we pick this 7 and this one, we can also generate one of the combination, but it's a similar combination which is present already in my set, so I can't do that. I have to have, I can't add the duplication. So for if this set is this combination is present in my uh, set, I didn't pick this because it's already present, so why I do the duplication thing? So I have to remove duplication. So that's pretty much simple, straightforward. You have to generate all the combination which sum is equal to 8. So there are 4 possible combination is there, you can see, and that's it. That's the question. So how can we approach this question? That's it. It's our main motto. So what's actually is on my mind? I can use the same logic which I use in the combination sum. I can use the same logic. So let's try to use that logic here too. In the combination sum, let's resize my ID. I guess you understand. So what I do, first and foremost, what I'm doing, I make my answer this I made my answer vector globally, and here what I do actually, I call over my solve function, and I assume this solve function do its own job. It's added all the possible combination into this ans variable ans 2D vector, and after that what I'm going to do, I have to return this ans. That's all what I'm going to do. So one thing I can do, I can pick this 10. If this 10, okay, let's complete this solve function too. So one more thing, one parameter I should pass it, because I need a one temp thing which is stored the dynamic combination, and after, if this combination is possible, then I'll add it into my ans. Otherwise I didn't add, so I just made it for my sake of ease. So let's pass it this candidate here. It's a basic parameter which I needed, and this target too, uh, this target, and after that I'll pass it in the combination sum. I'll use it, pass it this size. Let's go with the 0 indexing. Now I'm in the combination I traverse from here. let's try to traverse from here for you understand more. I can use the same logic from here to here, but it's a totally similar sometimes. So I've let me change something for open your mind how to approach this question. I can I can use the last index, but or make it, or maybe use the first index, zeroth index. So I'll try to solve this problem with the zero index. See, after that I pass my temp. So that's pretty much about, and this is done their job. Okay, and after that what I'm going to do, I'm done with that. Now my one duty is that I have to complete my solve function, and that's it, that's work. And my this solve function is actually void type because it doesn't take, it doesn't return anything, so it's a void type. And let's complete our solve function. And this solve function, take the first parameter, let me copy this thing for our seek of ease, and let's change the target name to ts because it's easy for write and understand. And let's candidate is not, it's an array. And let's write its idx. Okay, let's idx. And last one, it's a temp, so vector int temp. So that's the basic. Let's complete this, try to complete this. So my first thing, if my target sum is equal to 0, what does it actually shows? It shows, let's come to the after that sometime. Let's work for the else part. So, and I guess it's a little bit, I don't know how many times this one is come. I don't know stance is present one time or two times. So it's not easy for me to, if I don't know about this one is present two time, three time, or maybe one single time. So it's totally hacked because if all it distincts, I can use my previous logic which I use. If I don't, if I don't think about, if I know I solve this problem. Actually, I don't know about this one is present one time or two times. So that's the problem. If I know this one is present one time, so it's not creating any issue. But if this one is present two times or three times, it may be possible I make some duplication. So for removing the duplication process, what I'm going to do, let me just do one thing. I sort my this candidate. So let's copy this. Control C. So I want to sort this thing. Begin dot. So I sort this candidate series. Now it's sorted at a 1 1. So here I can observe this one is present two times. If I check out for the next index, or so it's easy to understand it's present one time or two times. So let's come to the for part. So what I actually do, here I'm using the backtrack, or it's a recursion type. So I try to backtrack, or you understand more clearly, let me write some code. So what I actually do here, array dot size I plus plus. Okay, what actually we do here, I just look at this. Let me just what I do here, I'll just sort this array. Now it's a one. Let me write here for your sake of ease. It's a 1 1 2 5 6 7 and 10. So I'm looking for this solution which is started from this one. I look up for the all solution, all combination which which I can which I can make the summation equal to target sum. After that, I didn't work on that. If I do all the work for this one, let's say I'll generate all the possible combination uh, which is equal to which sum is equal to my target sum. So I can't do for it because I've already done for this one too. This one. So it's a similar. So I'll just skip it, and now I try to find all the solution which is started from this two and go onward. So that's my approach actually. That's why I'll just use it. So whenever my array, if whenever, so in that case, let's say my target sum 8. Let's say I reaches to here 10, and let's here 11, 23, 32. Let's say I'm here 10 at the position of 10. So what I know, if my array I is greater than my ts, what it actually mean? It means I can't able to make array. I can't make able to make a combination. So in that is the case where I have to just directly return it from here. I don't need to make any computation, because if I what I do, I try to find out all the combination from this one. I try to find all the combination which is started from this two. I'll try to find out all the combination which is started from this 5, this 7, this 6, this 7, and this 10. If I try to find out all the combination which started from this 10, I can't make it because that 10 is greater than the TS, target sum, and every number in that given array, actually it's all positive numbers. So it means I can't able to make a sum uh, which is equal to target sum, because that's value is greater than a target sum. That's why I'll just return it from here. Okay, so that's one of the, and one thing, if I done the work for this, I don't want to doing the work for it. So I'll make it one more condition, and let's, if array I is equal to array I minus 1. So I don't want to, but here let's, it's an initial, when my I is equal to 0, so it's a out of bound. So that's why I'll just when my I is greater than 0 for this condition. So it's handle the what, the out of bound cases. So in that case, what I'm going to do, I have to continue. Okay, and one more thing, and if my I is greater than my idx, what it's actually mean? Let's say I'm looking for the solution. Let's say here is a 2 times, and I'm starting from here. I can possibly pick this 2 to both of 2. That case also true. So in that case, it is possible I pick this 2 and find out the solution, or I left this 2 and pick this 2. So it may be make some duplication. For that's why I'll just added one more condition here, and that's all. Now that I have to do some basic things which I have to do. What I do, uh, what I do actually, I just I think I have to pick this element. What I actually do here, I I'll try to pick this element. Okay, I'll pick this element and try to find out the solution. Is it possible to find a solution? If yes, so it's going to print it in this condition. If not, or it find it or not, What I do, I try, if I pick this element, I can generate a solution or not, I can make possible to generate a solution or not, doesn't matter it's possible or not, I try to find out from this way. And after this, from this way, from this element and from this element. So what I actually do here, in my temp I'll edit this array I element and looking for the solution. Is it possible to make solution from here? So array, so here is I'll subtract it from array because I'll add it, and after that it's I'll edit my idx to I plus 1, and that's temp, and this going to do its own job because recursion can do its work. And after doing what, it's give me true or not. If it giving me true, it going to read it, it add the answer, otherwise not. If I can't able to, let's say, if I can't able to from this 5, let's say I can't able to make a combination from this one, so I have to remove this one if I can't able to make. So I'll just pop it from my temp. That's it. Let's complete my TS. If target sum equal to 0, it means I have to push back this temp and return it from here. So that's it. Let's run this code, guys, and it's accepted. Let's submit this code, and it's accepted. So if you have any doubt, let me know in the comment section. I resolve your doubt as soon as possible. Until then, keep grinding, guys.